warahmatullahi wabarakatuh. Perkenalkan, nama saya Wida Pratiwi. Saya adalah mahasiswa dari Magister Teknik Elektro Universitas Diponegoro Semarang. Di sini saya akan memaparkan tentang paper saya. Sebelumnya saya lanjut ke paper saya akan memberitahu nama untuk pembimbing saya, yaitu Bapak Agus Sofian dan Bapak Iwan Setiawan. Baiklah, I will be start to presentation about my journal, about my paper, and then the title about the implementation of Fuji Logic method for automation of decision making of Boeing aircraft landing. Okay, the next page. In this I will be going to introduce this. This is air traffic controller. This is a BMKG and then research, and it is a codification for the Fuji Logic. The one of the next slide with one direction and wind velocity. This one direction element is needed to determine when where the plane landed or calculating current wind velocity while during the trip is used to maintain at the position when the aircraft landing position. And then this is a crosswind chart. If you can see, this is a danger zone and this is area direct crosswind. It is one velocity and it is one angle. If you see, this line, danger zone, is lined to 19 until 17, and it is area for the danger zone. This is a crosswind chart for the position of the wind position. And then visibility and pilot experience. If you know that regarding visibility for aircraft, the most important for the landing position, that are not automatic. Visibility is information is needed in time of landing. And then pilot experience. Pilot experience is one of the important factor in aircraft safety when landing. The pilot experience is operating the aircraft, and then it's also relative to weather conditions that exists during aircraft landing, where a pilot who has high number of hours of flying vertically refined to land an aircraft. And then research method. This is a Fuji Logic. Why I'm using the Fuji Logic? Because Fuji Logic is an achievement of Boolean logic that deals with the concept of partial. Boolean logic states that everything can be expressed by terms 0 or 1, yes or no. And then Fuji Logic is used to replace Boolean logic. And then the Fuji Logic has two stages, namely Fujification and then interference system and defugification. Fujification is the process of mapping the input values obtained from a system governed by the Fuji membership of the function. And then this is a flow chart. If you see that the slide flow chart, you can see the input, fujification, evaluation rule, defugification, and automatically output. This is one of the value of linguistic variable. If you can see one velocity, 0 until 5, this is low, and then 3 until 13 is average, 10 until 30 is high. If you see to one direction degree, in one direction degree, if you can see the criteria for the set 80 until 180, and then the visibility until this, you can see that far, medium, and near, and the other pilot experience, you can see the variable height and low. And then this is a one velocity graphic. This one velocity graphic, this is X of danger of membership and then Y of the particle. If you can see the low, maybe you can see low until danger membership 1 until 5. And then average, maybe you can see it is 4 until 14. And the next you can show the one velocity graphic. And then it is one direction graph. For the direction set, it is the same with wind velocity, but it's different. We can set the result, danger relatively and safe, kemudian safe, relative shape, and danger. And then the visibility graph. in the feasibility graph of the variable near and medium and far. It is 3 variables. It is a pilot experience graphic. In this pilot experience graphic, you know that near or far for the landing position if the pilot using this aircraft. And it is an evaluation rule on the system of the physiologic differentiation. And you can see that when velocity until 1 until 25, it is all of a file of the data and physiologic to confirm, compare, and this diagram. It is a function implementation for the rule. The implementation used is mine. You can see that the rule and then the rule composition, the composition of the implementation, function rule, and 3D specification using the centered method. It is a pattern for the differential. And then plus is only as the result and discussion. For in this section, we provide measurable result for physiologic calculation. Calculation have been 25 data for Ernap Ahmad Yani Airport, Semarang, represent some of the rules that have been met. And then measurement, where with using analysis of the data processing result, namely by comparing variability of data. And then for the data, we can know the BMKG or meteorology, because meteorology can send data every 30 minutes in our system. It is a data of measurement of the data result until 1 and 15. It is accurate because we find the file with meteorology data. It is a graphical user interface. It is a final display for the method of physiologic differentiation and implementation physiologic method for the automation decision making during aircraft landing, one velocity, one direction, visibility, and pilot experience. It is calculation for this paper. This paper presents the proposed physiologic for intelligent aircraft landing decision system. Several factors, the aircraft landing decision is the most important, and because the recent aircraft landing decision for physiologic and the data for the Adap Ahmad Yani Airport in Semarang have F9 different data results, but the difference is not very far because the difference between the real probability and the system probability. So it can be said, and that the physiologic system work quite well. And then in the future, it's expected that research related and then pilot and agency officer is greatly helped by the existence of aircraft landing system. Maybe this is only of the presentation about the physiologic, and the next I will be sharing for you for how about the system of the physiologic. Wait the moment. Udah mas, stop dulu.